Hey guys, it's Rhett here. The example I have for you today comes from Unit 4 Chemistry, and it's actually a bomb calorimeter. So we're going to look at calibration factors and then using the calibration factor to work out the heat content. So here we have a student who wants to determine the heat content of a biscuit. And first of all, the student performs this calibration and passes a current of 2.5 amps at a potential difference of 9 volts through the heating coil for 2.5 minutes. So this is basically putting in a given amount of energy into the bomb calorimeter and then observing that the temperature rose from 25.91 to 30.22. So this will enable us to calculate the calibration factor. Next, the student takes this dried biscuit. So again, there's no water in the biscuit, just dried biscuit, and of a mass of 2.42 grams, and combusts this in the calorimeter with excess oxygen and observes that the temperature rose from 25.75 degrees Celsius to 27.98, and we want to calculate the heat content of the biscuit. Okay, so the first step here is to work out the calibration factor. CF is equal to energy divided by delta T, the temperature differential. So here, the energy put in is simply the voltage multiplied by the current multiplied by the time. Divide that by delta T. Subbing in all of the numbers, so we had 9 volts times 2.5 for the current, and now the time is 2.5 minutes. For SI, I need this to be in seconds, so it's going to be 2.5 times by 60 to convert the minutes into seconds. And my temperature differential, don't get confused here, we are taking this temperature rise, not this one. We have to do the calibration first, so that's 30.22 minus 25.91. Okay, sorry, you didn't see that. So I'll just punch that into the calculator. So 9 multiplied by 2.5 multiplied by 25 is 60, and then divide that by the 30.22 minus 25.91, and I get 783.06. Now the unit here is joules, the amount of energy we put in per degrees Celsius of temperature rise. Okay, so once I have this calibration factor, I can then work out the amount of energy that was released when this biscuit was combusted. So the energy of the B here, energy for the biscuit, is equal to the calibration factor multiplied by the temperature rise. Now this is for the combusting biscuit. So here I have 783.06 multiplied by 27.98 minus 25.75. Now note here I've just been using degrees Celsius throughout. You can use degrees Celsius or Kelvin for this question, it doesn't matter because we're simply taking the difference of the two temperatures, so I'll just leave it all in degrees Celsius. So I take the 783 and I multiply that by 27.98 minus 25.75, and I'm left with 1746.23 joules of energy that was released. And finally, to work out the heat content, the heat content is how much energy is released per gram of biscuit. So we've got the 1746.23 joules of energy, and that all came from a biscuit which had a mass of 2.42 grams. So divide it by 2.42, divide it by 2.42, and I get 721.6. Now, just looking at significant figures, looks like I had 2 was the least number here, so I could just round this to 7.2 by 10 to the 2, and the unit here is joules per gram. Okay, and that's the end of the question, guys. As always, thanks for watching, and feel free to like and subscribe. Good luck with chemistry.